This video is just going to be a continuation of lesson 5. So in the beginning of lesson 5, we looked at the unit circle, we looked at special right triangles, and we also looked at finding reference angles. So we're going to start piecing together those ideas to be able to find the exact value of a trig function. So before we do that, there's one other thing we need to talk about, and it's called coterminal angles. And basically, coterminal angles, if you look at the word coterminal, it means they co-terminate. They end at the same place. So coterminal angles would be angles that terminate at the same point. So to kind of show you what that looks like, let's say I have some angle. So let's say this is 250 degrees. Coterminal means if I start at 250 degrees, so let's say I have this angle that starts at 250, I can add 360 to that, so basically go around on a full loop, and I end up in the exact same spot. So let's say I start with my 250 degrees, the same angle, and I add 360, and then I add another 360. I end up in the exact same spot. So you can add as many multiples of 360 as you want to 250, and your angle will always end in the same spot. So those angles, 250, 250 plus 360, 250 plus 360 plus 360, are going to be the same angles. They end up being in the same position. Same thing with if you started at this angle. So let's say I start here and I subtract 360, so now I go the opposite way. I end up in the exact same spot. So you could subtract as many 360s as you want, and you're going to end up in the same spot. So really, when you think about coterminal angles, you want to think of it as any angles that you can add or subtract 360. Any of those numbers that you get would be this ending in the same spot. So they would be coterminal angles. So for example, if I look at negative 50, since it's negative, I'm going to make it a positive angle. So I'm going to add 360, and I end up getting 310. So if you look, these two angles are coterminal because if I start at negative 50, that means I would be going clockwise 50 degrees. But if I do 310, that means I'm going the opposite direction all the way until I get to 50 degrees less than 360. So this would be my 310. So these two angles are coterminal because they both end in the exact same spot. So looking at another one, number 2 here. If I have 520, I'm going to go smaller with this. I could add 360, go another time around the circle, but for the numbers that are bigger than 360, I would subtract the 360 degrees, and you'll be able to see the angle a little bit easier. So we end up with 160. So 520 and 160 are coterminal because basically if you think about 520, you have 360 degrees, so you go completely around. And then you go all the way until you get to 160, which would end up being somewhere over here. So 360, and then the leftover is 160. Or you could have just went 160 degrees from the beginning. So basically those two angles end in the same exact spot. So that's kind of the visual representation, but really if you just think of it as adding or subtracting 360, that'll get you your coterminal angles. So when I look at number 3, if I subtract 360, I get 480. There's still another 360 in there, so I'm going to subtract off 360 again. Even though these two are coterminal, I'm going to find another coterminal angle. So if I subtract 360 again, I get 120. So basically all three of these would end in the same spot because they're I just subtracted off 360 or a multiple of 360. The last one here, I'm going to add 360 since it's negative. So I have plus 360. We end up with negative 40. Since it's still negative, I'm going to add another 360 to it, and we end up with 320. So all three of these would be coterminal. They would all end in the same spot. So the next thing to look at are, again, talking about these reference angles and being able to use this whole idea of reference angles, coterminal angles, and our unit circle and our special right triangles to be able to come up with exact values. So not decimals, but exact values. So what we're going to look at here are our reference angles. So remember, reference angles, you have the bow tie. So it looks like this. So reference angles are always the angles that are measured off of the horizontal axis. So all of these angles here are reference angles. And another important thing when we're looking at these reference angles is what's positive in each of these quadrants. So we have quadrant 1, 2, 3, and 4. And in the first quadrant, all of the trig functions are positive. So all of them, meaning sine, cosine, and tangent, because these are our acute angles. In the second quadrant, the only thing that's going to be positive is sine. So they're all positive here. Sine is positive in the second. In the third, tan is going to be positive. And then in the fourth, cosine's positive. So the way that I remember how this is, which trig functions are positive in which quadrant, I think of it as A, so all S students take calculus. So all students take calculus is the way I remember the acronym for this, or the what needs to go where. So this is going to be useful because it's going to tell you if the trig function in this quadrant is positive or negative. And once you know if it's positive or negative, then you just use the reference angle. So let's look at some examples to kind of show you what I mean. So for this first one, sine of 340. The first thing you want to do is you want to figure out where is 340 located. So when I go around, I know that 340 should be somewhere in the fourth quadrant. So this would be my 340 degrees. So the reference angle on this would be 20 degrees, because the entire thing's 360, subtract off the 340. So the reference angle is 20. And then what that means is this expression, sine of 340, is going to be equal to sine of 20, either the positive or the negative of that. Because remember, these are coterminal angles. The 20 degrees and the 340 end at the same spot, so they're basically equivalent. So what I do have to keep in mind, though, is the sine. So this is where we have all students take calculus. So in this fourth quadrant where my angle is located, cosine is the only thing that's positive. So that means since now I'm looking at sine of 20, I have to negate that. Sine's going to be negative down there. So sine of 340 is the same thing as negative sine of 20. And we're just going to leave it just like that for right now. We'll worry about evaluating them after. So the next one here, I have cosine of 150, so we're going to start with drawing out 150. 150 should end up in the second quadrant. So my reference angle for this is going to be 30, because 30 plus 150 gives me the 180. So I look at all students take calculus, so sine is what's positive. So this is going to be equal to a negative, because I'm looking at cosine and sine's the positive, and it's going to be equal to cosine of 30. It's always going to be of the reference angle. Okay, let's look at the next one here. So tan of 215. So 215 is going to, we always start here, go past 180, down into the third quadrant. Your reference angle for this one, so if you do 215 minus the 180 degrees that we don't want, that'll get you the reference angle. So the reference angle is going to be 35. So all students take calculus. So tan of 215 is going to be equal to tan of 35. And it is going to stay positive because tan is the positive trig function in the third quadrant. So it's just going to be tan of 35. And if you don't believe these, you can actually put them in your calculator and you'll get the same decimals. The whole reason why we're doing this, though, is so that we can get these exact trig values. So looking at this next one here, sine of 200. So 200 degrees will be in the third quadrant. So if this is 200 degrees, we want to find the reference angle. The reference angle would have to be 200 minus the 180 that we don't want, so we get 20 degrees. Since tan is the only thing that's positive, and this is sine, it's going to become negative sine of the reference angle, 20 degrees. So that's really the process for these. Now let's go to the next page and let's look at how do we actually get a number for these. So instead of leaving it as a trig function, how do we evaluate it? So let's go to this last set of examples here. And this is what we call finding exact values. So for this one, we have 240. So we're going to start it off exactly the same way as what we just did. So 240 is going to end up in the third quadrant. So we're going to do 240 minus the 180 degrees. So we get 60 as our reference angle. So this is going to be equal to cosine of 60. And then we have to decide if it's positive or negative. So if we label our quadrants, all students take calculus. The only thing that's going to be positive in this third quadrant is tangent. And since this is cosine, it's going to turn into negative cosine of 60. So then I'm going to keep the negative, and instead of leaving this as cosine of 60, I want to actually get an answer for that. So this is where our special right triangles are going to come into play. So remember we had our 30, 60, 90 triangles. This is going to be 2, this is going to be radical 3, and this is 1. So if I'm looking at cosine of 60 is ca. So cosine of 60 is adjacent over hypotenuse. So 1 over 2. And then we keep the negative, and there's your exact value for this. You could put any of these into your calculator, and you should get the same thing, negative 1/2. So let's look at tan of 330. So same idea. 330 will be somewhere down here in the fourth quadrant. The reference angle for this then is 30. So we know that this has to be equal to tan of 30, but we have to decide, is it positive or is it negative? So looking at our acronym here, all students take calculus. In the fourth quadrant, the only thing that's positive is cosine. So since this is tan, it's going to be negative. And then we're going to find tan of 30. So tan, remember if we're looking at SOHCAHTOA, tan is opposite over adjacent. So if I start at 30, opposite over adjacent is 1 over radical 3. So this is going to be 1 over radical 3. And then we have to rationalize that. So we end up with negative radical 3 over 3. Okay, so looking at cosine of 570. First thing I want to do, since this is bigger than 360, I'm going to go ahead and find the coterminal angle, so meaning subtract off 360 from that. So this ends up being cosine of 210. Instead of going around the circle and then figuring out how many degrees you have to go, just subtract off 360 as many times as you can until you get a number smaller than 360. Use the coterminal angles here, so you don't have to just draw around and around. So now that I get 210, I know that 210 ends up somewhere in the third quadrant. So if it's in the third quadrant, the reference angle you're going to find by doing 210 minus the 180, so we get 30. Then we have all students take calculus. Since this is cosine, that means it's going to be a negative, because down in the third quadrant it's tan. Negative cosine of 30 degrees. So we keep the negative. Cosine of 30, so if we look back up here, cosine is adjacent over hypotenuse, so radical 3 over 2. And then the last one here, finding an exact trig value. So we have negative 45. Basically, for this one, so negative 45, you can add 360 to it, or since it's negative, just think about it as going the opposite direction. So here's my 45-degree reference angle. So this is actually going to be equal to sine of 45 degrees, but I have to decide, is it negative or is it positive in this quadrant? So all students take calculus. The only thing that's positive down there is cosine, so sine's going to be negative. So we're going to keep the negative, and then we look at our 45, 45, 90 degree triangle. So if I have my 45, 45, 90, the easiest way to remember this one is radical 2 times 2, or was 2 for the hypotenuse. So if I'm looking at sine of 45, sine is opposite over hypotenuse is going to be radical 2 over 2. So then the very last thing in this lesson is going to be converting between radians and degrees. So remember we talked about it in that chart in the first part of the lesson, and in the chart you saw some things like pi over 3 or pi over 2, and how does that translate to degrees. So pi is thought of as 180 degrees. So the conversion here, if you want to go from degrees to radians, you're going to take the degrees and you multiply it by pi over 180. So basically what you're doing is you're dividing your degrees by 180. You're figuring out how many groups of pi go into it. So how many groups of 180 go into it. Where from radians to degrees, you take your radians and now you're trying to figure out how many groups of pi are in there, and then you multiply that by 180. So essentially you're dividing everything by pi and then multiply by 180. So for the first ones here, we want to convert to radians. So that means I'm going to be using this first box here, this first formula. So if I have degrees, I'm going to first divide by 180, and then I'm going to multiply by pi. So if you were to do this in your calculator, you're really putting 115 over 180 in your calculator and doing math frac, and then you're just going to keep the pi. You don't want to put the pi in your calculator. So you end up with, if you do 115 over 180 and then turn it back into a fraction, you end up with 23 over 36, and our answer should have pi in it. This one down here, we have times, again, pi over 180. So basically you end up dividing 532 divided by 180, and you should get 133 over 45 for that, and then we just keep the pi. This one here, same thing. It doesn't matter that it's negative. You're going to do the exact same thing. So pi over 180. And all it means is you're going to get a negative answer. So if I do negative 216.35 divided by 180, you end up with negative 4,327 all over 3,600. And then we keep our pi. And then the last one here, same thing. Multiply by pi over 180. So essentially divide it by 180. And then if you can get it into a fraction you want to, then put the pi back in your answer. This one won't actually come out to be a fraction, so I'm going to just write it as a decimal. Negative 0.00461. And I'm going to put pi in that. Okay, so then the very last thing is going the opposite direction. So if you start with the radians this time and we want to convert it to degrees, what you do is you multiply by the reciprocal of what we just did. So you're going to do 180 over pi. The reason for this is so that the pi's cancel. So you end up with 180 over 7, which ends up with 25.714 degrees. Essentially, what you can think of this is you're just replacing the pi with 180. So if you don't want to think about the pi's canceling, just think of it as I'm plugging in 180 degrees for pi, and that's what you'll get. So for this one here, again, we need the pi to be in the denominator so that it's canceling, and essentially we're just plugging in the 180 for this pi. So we cancel out the pi's, and we end up with 337.5 degrees. Moving on to number 3, we do again 180 over pi so that the pi's cancel. And you end up with negative 756 degrees. And then for this one, there's no pi, but it's still considered radians because that's what it tells us, that it's negative 2 radians. So I still do the same process, 180 over pi. It's just I don't have a pi to let it cancel out, so I just have to use this entire thing in my calculator. So when we put that into our calculator, you end up with negative 360 over pi, which ends up with approximately negative 114.6 degrees. So being able to convert between radians and degrees is going to be important when we start talking about graphs, or some problems, like when we start talking about equations, some problems are going to ask for answers in radians, some will ask for degrees, so you have to be able to go back and forth. So just remember the rule. If you're going 2 degrees, 180 divided by pi. If you're going the opposite way, to radians, it's going to be pi divided by 180 is what you're multiplying by. So we've talked about several different concepts and ideas, but really our goal is to be able to convert and to be able to find exact angle measures.